go. 2011, number 5. Okay, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. An increasing function W models the amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation. dW dt is 1/25 W minus 300 for the next 20 years. W is measured in tons, T in measured of years from 2010. Use the tangent line to the graph of W at 0 to approximate the amount of solid waste the landfill contains at the end of the first 3 months. So I don't know W, so I'm going to use a tangent line and plug in T equals 1/4. Then it says find the second derivative, and I'm going to see if it overestimate or underestimate. Oh, okay, we know how to do that, talking concavity. And then I'm going to find a particular solution, so I'm going to solve the differential equation. Okay, you can do this one. This is a good one. It's nice to look ahead sometimes like that. So A, find the tangent line to approximate. So I've got to find the tangent line here. So I'm going to do it at t equals 0. So I've got to find, okay, so when t is equal to 0, what's the slope? Okay, slope. Well, let's plug it into dw dt. It's going to be 1/25 times, oh boy, W minus 300. What's W? Oh, when T is 0, what is W? W is the amount of landfill that's in there. There's 1,400 tons in there. This is one of those ones that, man, if you don't catch that, it's like, oh boy, this could be bad. Okay, so if you get to that situation, check things out. Just remember, what does W represent? Okay, W is the amount of solid waste at T equals 0. Okay, I got that. Okay, 1/25 times, again, no calculators on this one, 1,100, which is 44 if you divide that. And so my equation is going to be, tangent line is y minus, when t is 0, we know that W, or I should say y, is 1,400. So it's y minus 1,400 equals the slope 44 times x minus 0. So y is 44x plus 1,400. Okay, so there's tangent line. When it says to use that to figure out how much is there at the end of the first 3 months, so time is 1/4, so y equals 44 times 1/4 plus 1,400 is, of course, 1,411 tons. So make sure you use units. Okay, and that's kind of okay. B. Okay, find second derivative in terms of W. Second derivative. So d squared W dt squared. Okay, so I'm going to take the second derivative of that, leave the constant out, and the derivative of W is dw dt minus the derivative of 300 is 0. So it's just that simple. Okay. And what is dw dt? I know what that is. That's from the first equation. That's 1/25 times W minus 300. Ooh, they're throwing like some back substitute things in on you here. This would be 1/625 W minus 300. Okay. So, question: what do we know about the concavity here? Well, what do we know about the second derivative? What do we know about W? Well, W is always W is greater than 1400. D, second derivative. Isn't this always going to be positive? Yeah. So W is concave up. So, oh boy. So the tangent line is always below the function. And I can say always because this is always the case. Otherwise, I might have to just check the particular interval that we're dealing with. But let me just so you know this: 0 less than or equal to t less than 1/4. That's all we're really worried about. But I will make note of that if you just said 0 to 1/4, that's all you need. Okay, or equal to. Okay, thus the approximation in part A is an underestimate. Okay, C. Now, 2 points in this problem. This last part is worth 5 points. And I can almost guarantee you're going to have one of these on the real test this year. Find a particular solution to this differential equation. So the question is, how in the world do you do this? And I've got an initial condition right here. Okay. A few different ways to do this. Well, actually not really a few. I mean, you could, but you have to get the W's on one side and the T's on the other. So let's do this. Let's do dW over W minus 300. And I'm going to go ahead and leave the 125 dt. When I said a few, I meant I could bring the 25 over to this side, but I'm just going to leave it like that. Now I take the integral of both sides, and this becomes natural log absolute value W minus 300 equals 1 over 25 t plus a constant. Okay, I'm going to go ahead and, well, I'll give you the points here when we're done here. Okay, I want to find C, so I'm going to plug in the initial condition. The initial condition was W of 0 is 1400. That was my initial INIT. I can spell. It's getting late, so I'm going to plug it in here, and I get log of, I don't need absolute value anymore because I know this is positive, equals 1 over 25 times 0 plus C, so the constant is going to be the natural log of 1100. Okay, so my equation becomes the natural log of absolute value W minus 300 equals 1 over 25 t plus natural log of 1100. Now, at this point, since I know W has to be greater than 1400, I really don't need the absolute value signs here because W will never be less than 300. So I can actually eliminate those. Now, do I have to do any more than this, or can I leave it at this? Well, it depends what the question asks. Since the question says find the particular solution W equals W of t, I have to solve this equation for W. So let's go ahead and solve this for W. Now, since I don't need the absolute value here, I can just write these as parentheses here, since W is greater than 1400. No need for absolute value. That happens often. And I'm going to write this in exponential form because this is base e. So this is e to this power equals this guy. So W minus 300 equals e to the 1 over 25t plus natural log of 1100. So w of t is e to the 1 over 25t plus natural log of 1100, plus 300. Okay, now there are some ways that I can simplify this. I think you're okay doing this, but let's go ahead and simplify this some more. I'm just going to show you this, but if you left it like that, I'm sure you're fine. This is e to the 1 over 25t times e to the natural log of 1100 plus 300. And e to the natural log of 1100, those are inverses, they cancel each other, so you're left with 1100 e to the 1 over 25t plus 300. That's my function that I started with. Is there a limitation on the certain amount of time on here for the domain? And if you go back to the original problem, it says this function works for the next 20 years. So this really is only valid for 0 less than or equal to t less than or equal to 20. But let me go ahead and give you the breakdown on points for this so you know what you need to do on here so you get this. Let's see here. It was 1 point for separating the variables, so you get 1 point for getting the w's on this side and putting dw here and dt on this side. You get a point for taking the antiderivatives correctly. You get a point for putting the constant of integration there. You get a point for using the initial condition and getting that. And you get a point for solving for w correctly, for doing all of this. Okay, if you did not do no constant, the max you could get is 2 out of 5. So if you didn't do a constant, you would get this point here, and you would get this point here for doing the integration, but no constant, so you wouldn't do that point. You get 2 out of 5. If you didn't separate the variables, no separate variables, your max score is 0 out of 5, because that's the only way you can do it. So when you have to solve a differential equation, you have to separate the variables. Okay, there you go.